Statistical Rethinking, second edition. We're in chapter 11, and we're just beginning the medium difficult questions. We're on 11M1. So here's the question right here. So as explained in the chapter, binomial data can be categorized or can be organized as either aggregated or disaggregated forms, okay? Without any impact on inference. In other words, when we run the analysis, we'll get the same answer regardless of how we formatted the data. But the likelihood of the data does change when the data are converted between the two formats. Can you explain why? Okay, so I'm just using the chimpanzee data from the chapter. So this is just a screenshot of the textbook of a certain part. So in the aggregated data, it might look something like this, where importantly, what's going on is that the outcome variable left poles here is the number of, call it, successes out of however many trials. Okay, so so in other words, in this instance, for actor 1, for the first chimp, for the first treatment on the first side under the first condition, okay, they pulled left 6 out of 18 times. So so what you don't see here is that there's a total of 18 total trials, but anyway. And similarly, for the second row, it's the treatment 1, but now we're on actor 2, side 1, condition 1, and this one pulled 18, all 18, or pulled left all 18 times. Okay, so now this differs from the disaggregated data, where each, why is this aggregated data? Because we have aggregated 18 trials and just counted the number of successes. And the disaggregated data, it might look like this, where every single trial has its own row. Okay, so for treatment 1, actor 1, side 1, we have this, right? We have the outcome of that particular trial, and we repeated that trial, right? And this time there was also no pull, and then we repeated the trial, and this time we got a pull. Okay, so on and so forth. Anyway, so that's the difference between the two data or data formats. Okay, and so it may just be intuitively obvious that we do need to account for the different data formats. And so how do we do that? All right, so in terms of code, the aggregated data accounts for the fact that it's compiling many trials in each row here, right? So if this is the outcome, we need to define the likelihood. So we're defining the likelihood here, and we need to say for our binomial trials, or how many binomial trials we had, right? We had 18 trials, and ultimately we'll try to estimate P. Okay, but conversely, the disaggregated data, because we only have one trial per row, we just put a 1 in there. Okay, right? So our likelihood just says we have one trial for each row. Okay, so in math notation, this will look like the following. So in the disaggregated data, so we're in this case here. Okay, our likelihood looks like this. So it's P times the number of successes. So that's going to be 1 or 0. Y will be 1 or 0 times 1 minus P to the 1 minus Y power, right? So if there's a success, then we have P. If there's a failure, right, then we have this guy right here. Okay. But for the aggregated data, so we have a very similar looking likelihood, but now we have to account for the fact that we have 18 trials, and we also need this term out here, which is called the multiplicity, right? Which is basically the number of ways that we can get Y successes out of N trials. Okay. So that is it.